Hey guys, welcome back for another online lesson. This is lesson 8.7. What we're going to do is we're going to solve one-step inequalities. Let's do a quick refresher on how to solve for variables. In this case, we have an equal sign. C minus 8 equals 10. What we have to do is get C all by itself. So I'll start at the equal sign, and it's minus 8, so I have to do the inverse, which is adding 8 plus 8. If I do it to that side, I got to do it over here, plus 8. These two will cancel, leaving me with C equals 10 plus 8, which is 18. Perfect. Let's try this one down here. This is G plus 9 equals 10. I start at the equal sign. It's plus 9, so I have to subtract 9 from both sides. We're left with G equals, because those cancel, 10 minus 9, which is 1. You're going to use those same skills, and we're going to use them on inequalities. Ready? Erase that. Perfect. Okay. Here I have 5 times x is less than or equal to 45. Now, just like where we'd start at the equal sign, we're going to start here. We're going to split it off into two sides. With what we do to one side of the inequality, we have to do to the other side. In this case, is multiplying, so the inverse is dividing. So we're going to divide by 5, and we're going to divide this side by 5. Perfect. These will cancel, leaving us with x is less than or equal to 45 divided by 5, which is 9. Now notice what I did there? I just dropped whatever the inequality was, just like it was the equal sign. I dropped it right down. Boom. And there's our answer. X is less than or equal to 9. Here's another problem. P plus 13 is less than 45. That's my split. We're treating it just like it was an equal sign. And to get rid of that 13, we have to subtract 13 because it's the inverse of adding. Subtract 13 from both sides. Boom. Those will cancel, leaving me with P, and I just bring down whatever my inequality symbol was. In this case, it's less than 45 minus 13. 5 minus 3 is 2. 4 minus 1 is 3. And we're left with P is less than 32. Let's take it up a notch. Let's graph them. Okay. So sometimes you're going to be asked to not only solve the inequality or find the variable, you're also going to be asked to graph the result. And this is the case where we do that. Ready? Here I have 5 times y is greater than 30. So I start here. Y is on this side. I look at what do I do the inverse. The inverse is division. Divide by 5 to both sides. These two will cancel, leaving me with y. Bring down my inequality. In this case, it's greater than 30 divided by 5, which is 6. Perfect. Now that we have this information, we use it to graph. Y is greater than 6. So I start at 6, and I'm going to put my open circle, because 6 is not included when it says greater than. And y is greater than 6, so I'm going to fill in all of those lines that tell me it's greater than 6. And that is how we would graph the result of our inequality. Let me show you another one. This is w minus 1 is less than or equal to 4. There's my inequality, so that's where I'm going to divide it off. And because it's minus 1, we're going to add 1. And we're going to add 1 to this side. Perfect. Those ones will cancel, or bring us to 0. W, bring down my inequality. W is less than or equal to 4 plus 1, which is 5. Okay, now that we have this result, just take this information and use it to graph. Now, W is less than or equal to 5. So What I'm going to do is I'm going to find 5. And because it's less than or equal to, I have to fill it in. Remember, when it's or equal to, you got to fill in the circle to make sure the 5 counts. Now, it's less than, so we're going to go this direction. We're going to fill out all the numbers that are less than. Perfect. Excellent. So now we have the result that it could be 5 or any number less than. One more problem to do. The dreaded word problem. Nothing you can't handle though. Just go step by step. Erase. Perfect. Okay. A company charges $2 for each candy bar. My parents say I can spend no more than $12. Write and solve an inequality to find the maximum number of candy bars I can buy. Okay, step 1, what we have to do is extract all that important information. Company charges $2 for each candy bar. I can imagine that's probably pretty important. We're going to use that. My parents say I can spend no more than $12. Excellent. Write and solve an inequality to find the maximum number of candy bars I can buy. Okay, first off right away, I see no more than $12. So I know that we're talking about $12. And we're talking about $2 for each candy bar. Do we know how many candy bars we can get? We have no idea. So I'm going to let C be the number of candy bars. Because we don't know. We don't know how many candy bars we can get. That's what we're trying to solve. We do know it's $12 is the maximum amount of money I can spend. And we know that each candy bar is $2. So if I say it's $2 times the number of candy bars, 12 has to be bigger than or equal to. Now, let me show you how this reads. $2 times the number of candy bars that I get has to be less than or equal to $12. Let's solve for that variable. Here I split it, and because it's multiplying by 2, I'm going to divide by 2. Divide by 2. Perfect. These two will cancel, leaving me with C, which is the number of candy bars, is going to be less than or equal to 12 divided by 2, which is 6. Now some of you right now can probably look at this and say, oh yeah, that makes sense. I can buy 6 candy bars for $2 because my parents say I can spend $12. But C could be any number 6 or lower. Now let's graph it. And I'll try to draw a quick graph right here. And 0, and 2, 4, 6, and -2, -4, -6. Okay, so C is less than or equal to 6. So I go to 6, and I fill it in because C counts. And it's less than or equal to 6, so I'm going to shade in it that way. Perfect. If you have questions, jot them down. We'll see you in class.